Welcome back to the deep dive. We have a stack of documents today that is, honestly, it's a little heavy.
Yeah, that's probably putting it mildly.
Usually when we sit down, we're looking at a broad cultural shift, maybe a fun new trend, or some historical event that gives us context for today. But today, February 25th, 2026, we are zooming in on something very specific.
Right.
We are looking at a single image, a graph.
Which, I mean, it sounds completely dry when you say it like that. A graph?
Hmm?
People were probably reaching for the skip button right now.
Don't skip.
Yeah, do not skip, because this isn't just any graph.
No, it is not. This is the graph that has effectively taken the mood in Silicon Valley and, honestly, the global tech community at large, from what you might call feverish excitement to something that looks a lot closer to genuine panic.
It is the talk of literally every boardroom, every research lab, and increasingly, it's the piece of paper sitting on desks in government offices in D.C. and London. It's the thing keeping the smartest people in the room awake at night.
Exactly. So we are talking about the latest data release from an organization called METR. And if you haven't heard of them, don't worry, we're going to get into who they are and why they matter.
We'll break it all down.
But the headline for you today is this: the way we measure artificial intelligence, the ruler we use to see how smart these systems are becoming, is starting to look like that ruler just isn't long enough anymore.
And the specific thing being measured here, the new model from Anthropic, Claude Opus 4.6, is climbing this chart so fast that experts are just scrambling to figure out what happens next.
Yeah.
It's not just moving up and to the right anymore, it's going vertical.
So here is our mission for today's deep dive. We have a stack of reports, specifically a breaking investigation from Sky News involving interviews with METR researchers, plus the raw technical documentation from the evaluation itself.
Lots of dense material.
Lots of math. But we are going to explain exactly what this graph measures. And I want to be really clear here. This is for you, the listener, who might use AI, or maybe you just read about it in the news, but you aren't a machine learning engineer.
Right. You want to know why people are freaking out without needing a PhD in computer science.
Exactly. So we're going to decode the metric itself because it is much weirder than you might think. It's not an IQ score.
No.
It's not a trivia quiz. It's something much more fundamental about agency and capability. We're going to talk about the acceleration of the acceleration, which is a terrifying phrase on its own, and we are going to talk about what this means for your job.
Specifically if you write code for a living.
Yes, because there's one anecdote in our source material about a researcher and his pension that, well, it actually gave me a chill.
It's a very sobering detail, absolutely. It really changes how you look at your 401k.
Okay, so let's unpack this. First things first. Who or what is METR? Because, I mean, in 2024, nobody outside the very inner circle really talked about them. Now, they are the absolute authority.
Right. So METR stands for Model Evaluation and Threat Research.
Threat research.
Yeah, that name alone tells you quite a lot. They aren't there to market the product. Think of them as the independent auditors of the AI world. Or, maybe better yet, the really strict teachers who write the report cards that actually matter.
So OpenAI, Google, Anthropic, they build the models, they have their own internal tests, obviously.
Of course.
They're constantly putting out press releases saying, our model is 10% better, but METR is the third party.
Exactly. Because in 2026, with AI models becoming so incredibly powerful, you can't just take the company's word for it anymore. You can't let the student grade their own homework.
Makes sense.
You need a standardized, rigorous way to assess what these things can actually do in the real world. So METR assesses software development capacities. They were trying to figure out, basically, can this AI act like a human software engineer?
And when we say act like a human software engineer, we don't mean just writing a little snippet of code, right? We mean the whole job.
Correct. We're talking about the agency, the planning, the debugging. And their latest chart is the one causing this massive stir. So let's get a bit technical for a second, but keep it simple.
Let's do it.
What are the X and Y axes here? What are they actually measuring? Because I think people imagine it's like a Jeopardy test, like who won the World Cup in 1998?
Or write a poem about a cat in the style of Shakespeare.
Exactly. And it is definitely not a trivia quiz. That was the old way of testing AI back in 2023 or 2024, what researchers called MMLU, Massive Multitask Language Understanding.
Right.
That was just, facts. But METR focuses on agency. They measure the ability of an AI to complete a task.
Right.
But the specific metric is fascinating. They are measuring the length of a task that an AI can complete successfully 50% of the time.
Okay, hold on. I need to stop you right there because that 50% number, it just sticks out like a sore thumb.
I know it does.
That sounds terrible. If I did my job right 50% of the time, I'd be fired by lunch. If my calculator only worked half the time, I'd throw it in the trash. Why is 50% the benchmark for these superintelligences?
That is the crucial question, and it's where a lot of people get tripped up looking at this graph.
Mm-hmm.
You have to understand that METR isn't testing for reliability in a commercial product.
Okay.
They aren't asking, is this ready to be sold to a major bank? They are testing for the frontier of capability. They are trying to find the breaking point.
The breaking point. So it's a stress test.
Right. Imagine a high jumper. You keep raising the bar until they knock it down. The height where they clear it exactly half the time and knock it down half the time, that's their maximum limit.
That is their frontier.
Exactly. If they clear it 100% of the time, the bar is too low. You haven't found their limit yet. So METR is trying to find the maximum complexity that these AI models can handle before they collapse and start hallucinating or making mistakes. So the 50% threshold represents the absolute edge of what the AI is capable of figuring out.
I see. So it's not saying this product is ready to be sold on the shelf. It's saying this intelligence is capable of reaching this specific height. It helps us map the boundaries of the mind, essentially.
Precisely.
Yeah.
And the variable that is changing the bar they are raising in this analogy is the length of the task.
Okay, so when we say length, what does that mean in software terms? Because length sounds like time. Are we talking about minutes, hours, or is it about lines of code?
It's really a combination of time and complexity steps. We aren't talking about writing one line of code here. We are talking about human-level software engineering tasks.
Give me an example of what METR is actually throwing at these models.
Sure. Imagine I give you a command as an engineer. Go into this massive, messy legacy code base. Find the bug that is causing the main database to crash every time a user uploads a profile photo.
Oh, wow.
Fix the bug, write a test to make sure it doesn't happen again, and then deploy the update to the server.
That's not a question. That's a project. That's a complex chain of events.
It is. Think about what that requires. You have to understand the file structure. You have to read code you didn't write. You have to set up a virtual environment. You have to hypothesize where the error is. You have to fix it without breaking something else.
Right.
In the past, AIs could handle very short chains. Maybe write a function that sorts this list. That's a short task. But what METR is seeing is that the AI's ability to handle longer, multi-step, complex tasks is skyrocketing. They are testing how long a sequence of actions the AI can maintain coherence for without messing up.
So it's almost like testing attention span mixed with logical consistency.
That is a great way to put it. Can you hold the context of what you did 10 minutes ago while you make a critical decision right now?
So the graph shows the AI handling longer and longer lists of instructions without dropping the ball.
Correct. And that length is the proxy for intelligence. Because to hold a complex architecture in your mind and execute a fix requires reasoning, planning, and memory. It requires agency. And right now, that length is stretching out further and faster than anyone anticipated.
But I want to circle back to that 50% number for a second, because our sources make a really important point about the business reality of this.
Yeah, the commercial side.
If I'm a CEO listening to this deep dive and I hear 50% pass rate, I'm thinking, great, it's a coin toss. It's useless to me.
Yes. And this is where we have to be very careful not to confuse raw intelligence with automation readiness. As the experts in the Sky News piece point out, a 50% success rate is effectively useless for a company that wants to replace a human worker today.
Right. Because if I hire a digital employee and they delete the customer database every other time they try to update it, that's a disaster.
It's worse than a disaster. It's a massive liability.
Huge.
Even the 80% success rate, which METR also tracks, by the way, is essentially described by the experts as not close enough for full corporate automation.
Really? Even 80% isn't enough.
No, because in a high-stakes environment, think banking, healthcare, critical infrastructure, you need 99.9% reliability.
Yep.
You need Six Sigma levels of accuracy.
So the graph is scary because of the potential it shows, not because you can download Claude Opus 4.6 and fire your entire IT department tomorrow.
Exactly. It shows raw horsepower. It shows that the engine is getting massive, even if the steering wheel isn't perfectly attached yet. It tells us that the capability is fundamentally there. The reliability is just an engineering problem to be solved over time.
Got it.
And that brings us to the shape of the curve itself. Because it's not just that the numbers are going up, it's how they are going up.
The acceleration.
The acceleration of the acceleration.
Let's look at the data from the report. They note that AI is getting twice as good at these software tasks roughly every 7 months.
Just think about that for a second. 7 months. In the old world of software, we had Moore's Law, which said computing power would double every 18 to 24 months.
And that felt fast.
It felt incredibly fast. But that was just hardware speed. We're now seeing a doubling of capability of actual practical smarts in software tasks in less than a third of that time.
And the scary part, according to the sources, is that this trend used to be steady. But recent data suggests the trend itself is speeding up. It's not just a straight line up anymore, it's curving upward.
And that is exactly what has shifted the mood. It's the difference between linear growth and exponential growth. Humans are very, very bad at understanding exponential growth intuitively.
We really are.
We are built for linear worlds. If I take 30 linear steps, I cross the street. If I take 30 exponential steps...
You circle the globe 26 times.
Exactly. The source material brings up a very specific analogy here that I think everyone will understand, unfortunately. They compare this feeling to the early days of the COVID-19 pandemic.
That is a vivid comparison. I think we all remember early 2020.
Vividly. It feels like a lifetime ago, but the math is identical.
There was that period where the case numbers looked really small. They were doubling, but when you double 2, you get 4. When you double 4, you get 8. It feels manageable. The line looks flat.
The foothills, as researchers call it. You're walking along, and the ground is rising, but it's gentle. You think, oh, I can handle this hike.
Right. But the nature of exponential curves is that they look flat for a long time, and then suddenly, seemingly overnight, they just go vertical. The foothills become a sheer wall.
There is a quote in the source from a UK tech entrepreneur that sums this up perfectly. He describes the progress of AI as feeling like nothing, 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 everything.
Wow. That hits hard. Nothing, 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 everything.
It perfectly captures the deception of the curve. For years, AI was nothing. It couldn't really code at all. Then it was a little bit of nothing where it could write really bad, buggy code. And suddenly we are hitting the everything phase where it is doing things that seasoned engineers struggle with.
So we are currently sitting here in February 2026. Where are we on that curve right now? Are we still in the foothills?
The consensus from the experts we're reading today seems to be that we have left the foothills entirely. We are starting the vertical climb. The release of Anthropic's Claude Opus 4.6 was basically the flare going up. It broke the records in a way that suggests we are entering that steep part of the curve.
And this isn't just data points on a screen for these people. This is affecting the actual researchers who build this stuff. The emotional reaction described in the report is intense. We aren't talking about dry academic interest here. We are talking about literal panic.
Genuine anxiety.
Okay.
These are people who have dedicated their entire lives to this field, and they are looking at their own creation with this mix of awe and terror.
Yeah, there's this quote from a METR researcher in the Sky News piece. He apparently sent a note to his old college friends, just a private group chat, and he ended up posting part of it publicly. I want to read it because it feels so raw.
Go ahead.
He said, quote, "I feel very confident now that it's going to be totally insane and chaotic, like many orders of magnitude more chaotic than anything the world has experienced in our lifetimes," end quote.
Totally insane and chaotic. That is not the kind of language you usually hear from scientists who evaluate metrics for a living. Usually, it's statistically significant deviation or unexpected variance, not insane and chaotic.
No, it sounds like a line from a disaster movie or some kind of prophecy.
But it reflects the reality of the data they are staring at every day. When you see a curve go vertical like that, you realize that the world of next year is going to be fundamentally, structurally different from the world of today. And that predictability, the basic stability we all rely on to plan our lives, is just evaporating.
It's interesting you mentioned stability because one of the biggest themes in this deep dive, and something I really want to make sure you, the listener, understand, is the idea that our ruler is running out. We are facing a measurement crisis.
Yes, this is the grand irony of the whole situation. As the AI gets smarter, measuring how smart it is gets harder. It's what the sources are calling the fog of war in AI evaluation.
The report mentions that METR researchers are increasingly nervous about the specific dots on their own graph. Which sounds crazy. Why? If they're the ones designing the tests, why are they nervous about the results? Shouldn't they know the score better than anyone?
You would think so. But it comes down to confidence intervals. In statistics, a confidence interval basically tells you how sure you are that the true number lies within a certain range.
Oh.
And regarding Claude Opus 4.6, METR admits there is a very large range of possible values.
So they're saying, we think it's this smart, but it could actually be way smarter or maybe a little less smart, and we honestly don't know for sure.
Exactly. And the reason for that intense uncertainty is what you might call the teacher-student problem.
Walk me through that.
Okay, imagine you are a high school math teacher. You can easily grade a math test for a 5th grader. You can grade a test for a 12th grader. But what if you suddenly have a student who is a once-in-a-generation mathematical prodigy, someone who is inventing entirely new branches of math that you, the teacher, don't fully understand?
Right, it becomes very hard to grade their tests. You don't know if they're right or if they're just hallucinating something that sounds brilliant.
It becomes almost impossible. The METR researchers are admitting in these reports that it is becoming incredibly difficult to find software tasks that are hard enough to properly test these new models.
Wow.
The AI is outpacing the exam.
I love the analogy we were discussing before we started recording.
Yeah.
It's like trying to measure the speed of a supersonic jet using a stopwatch and a pair of binoculars.
That's perfectly it. You can see it's fast. You can see it went whoosh right past you.
Mm-hmm.
But can you tell me if it went Mach 2 or Mach 3? The tools we have, the human-level software tasks we use as benchmarks, are becoming too easy for the models. They're just breezing through them.
And why does this measurement gap matter to the average person? Like, why should you or I care if the scientists are a little fuzzy on the exact score of Opus 4.6?
Because the markets are moving based on these scores. Government policies being drafted based on these scores. Business expectations are being set by them. If METR is slightly wrong, if a few tiny tweaks to the test would show that the AI is actually much more capable than the current dot on the graph suggests, we might be drastically underestimating the speed of change.
Meaning we think we have 2 years to prepare for a massive wave of automation when we actually have 2 months.
Precisely. Or, conversely, maybe the progress is hitting a wall and slowing down, and we are panicking for nothing.
Though the sources definitely seem to lean toward underestimation being the bigger risk.
They do. The uncertainty itself is the danger here. We are flying into a Category 5 storm, and our radar screen is starting to glitch.
And there's specific fear mentioned in the report that links directly to this idea of unpredictable acceleration, the concept of self-improvement.
Right. This is the classic science fiction scenario. Recursive self-improvement.
The idea that an AI becomes smart enough to rewrite its own underlying code, making itself smarter, which allows it to rewrite its code even better, leading to this unstoppable intelligence explosion.
The singularity.
Exactly. We hear about this in movies all the time, but what did the documents actually say about the reality in February 2026? Are the machines building the machines yet?
So they spoke to Joel Becker, who is a member of the technical staff at METR. He addresses this head-on. And his current assessment is that AI is not yet able to fully improve itself autonomously. We aren't at the pure machines building machines stage. It still needs a human in the loop to review and click approve.
Well, that sounds like a bit of good news. A
Right.
bit of a safety valve, right?
It is, technically speaking. But there is a massive however attached to it in the report.
There always is.
Becker points out that while the AI isn't doing it entirely alone, AI tools are meaningfully speeding up the human professionals who build the AIs.
Ah. So the human researchers using the AI are building better AI faster than they ever could without it?
Exactly. It's a feedback loop. The AI helps the researcher write code faster and spot errors. The researcher uses that speed to build a better AI model. That better AI model then helps the researcher code even faster on the next iteration. The cycle is feeding itself. So even if the AI isn't strictly autonomous yet, the practical result is the same. Radical compounding acceleration.
It's like giving that high jumper we talked about a jetpack.
And then giving the jetpack a software upgrade every 7 months.
Which brings us to the part of the deep dive that I think hits the hardest, the economic fallout. We've talked about the abstract numbers and the speed of the curve, but let's talk about the human impact. There is a specific detail about Joel Becker, the researcher we just mentioned, that really stuck with me.
You're talking about the pension.
Yes, pension.
It is a small detail in the grand scheme of the article, but it tells you absolutely everything about his worldview right now. Joel Becker has stopped paying into his pension since he started truly understanding the trend in AI development.
I want you to just pause on that. A pension is a bet on the future. It is the ultimate act of faith in societal stability. It's saying, I will put my hard-earned money away today because in 30 or 40 years, there will be a stable economy, I will be retired, and I will need this currency to live.
And Becker is effectively betting against that stability. He is looking at the graph, that vertical line, and he's thinking, The world 30 years from now will be so radically different that the concept of a pension, or traditional savings as we know it, might be completely irrelevant.
That is a visceral example of how serious the insiders believe this disruption will be. It's not just, oh, the stock market might dip a few points next quarter. It's the fundamental structure of how we live, work, and age is going to break apart.
It implies a belief that we are heading toward a paradigm shift where the rules of the past simply no longer apply. If money becomes meaningless, or if the economy transforms into something post-scarcity because AI is doing all the labor, then saving 5% of your paycheck today is like saving seashells.
So if the pension system is in question for the long term, what about the jobs right now? Specifically coders. If METR is specifically testing AI on software tasks, are coders, as the kids say, cooked?
This is the multi-trillion-dollar question. And the answer is complex because the data right now is actually conflicting.
Yeah, on one hand, the report says that employment stats in the UK and the US show very little impact so far. In fact, job ads for software engineers on platforms like Indeed are actually rising here in early 2026.
Which seems completely counterintuitive, doesn't it?
Yeah.
If the AI is so incredibly good, why are companies hiring more humans?
Right. It feels like a massive contradiction. We keep hearing AI is taking over, but the data says we are hiring more engineers.
Becker explains this with what we call the lag effect.
Yeah.
You have to remember that economic statistics are a rear-view mirror. They tell you what happened 3 months ago or 6 months ago.
And the release of Claude Opus 4.6 and these massive vertical breakthroughs on the METR graph happened in the last few months.
Exactly. There is a massive delay built into the system. A breakthrough happens in a research lab in San Francisco. It takes time for that breakthrough to be packaged into a usable enterprise product.
Sure.
It takes time for a CTO at a mid-level company to decide to buy that product. It takes time to integrate it. And it takes even more time for the company to realize they don't need 50 junior engineers anymore. The actual layoff happens a year or more after the initial technological breakthrough.
So the job ads we see today on Indeed are the result of corporate decisions made before this vertical climb really kicked in.
Precisely. We are seeing the ghost of the old economy. The technological shockwave has happened, but the economic tsunami hasn't hit the shore yet.
So does Becker think coders have a future at all?
He says they have a future, quote, for a while at least.
For a while, at least. That is not very reassuring.
No, he points out that the AI professionals inside the labs, the ones actually building these advanced models, are doing real complex work and will likely continue to be needed for the next year or maybe many more.
But the fundamental nature of the work is changing.
Completely. It is shifting from writing code, like physically typing out syntax and finding missing semicolons, to orchestrating AI. You stop being a bricklayer and you become a manager of digital workers. But the lingering question remains, do you need as many managers as you needed workers?
Probably not.
Right. If one software architect can do the work of 10 engineers by commanding a fleet of AI agents, you hire one architect and you don't hire the 10 engineers.
And this brings us back to the market reaction. We touched on this, but you mentioned earlier that markets are moving on vibes right now.
It is a highly dangerous situation. Financial markets crave certainty above all else. They want neat spreadsheets that predict Q4 earnings down to the penny. But right now, they are reacting to these METR graphs, which, as we discussed, the researchers admit are full of uncertainty.
Small changes in the METR assessment cause stock prices of tech giants to swing wildly.
And Becker makes a really noble point here in the report. He says, we don't want to hide behind that uncertainty. I think that's real uncertainty. He is openly admitting that they don't have all the perfect answers, and the market shouldn't pretend that they do.
It seems like everyone, investors, engineers, the public, is trying to figure out if this acceleration is ultimately a good thing or a bad thing. And the answer from the documents seems to be yes.
It's the double-edged sword of acceleration. Becker puts it very clearly.
He wants to communicate that the situation is serious, it's fast-moving, and it is accelerating.
And he says this could lead to extraordinarily positive possibilities.
Which is true. Curing complex diseases, solving the energy crisis, creating massive economic abundance. Imagine a piece of software that can decode human biology and cure a specific type of cancer over a weekend. That is genuinely on the table if this curve continues.
But on the flip side, he warns of extraordinary, dangerous things. Destabilization, misuse by bad actors, massive job displacement, or even a loss of control over the systems themselves. The core concern for these researchers isn't just the final destination, it's the speed of the journey.
Because when you move this fast doubling capability every 7 months, You have very little time to adapt as a society.
None at all. You can't build safety nets. You can't pass thoughtful legislation. You can't retrain the workforce. The next wave of change hits you before you've even processed the last one.
So let's try to bring this all together for you.
Hmm.
We've looked at the METR graph, this vital measure of software capability that is doubling every 7 months. We've looked at the weird metric itself, that 50% pass rate on increasingly long, complex agency tasks. And we've looked at the panic, the feeling among the smartest people in the room that we are suddenly scaling a vertical wall.
It's a massive amount of information to take in.
It really is. But if you take one thing away from this deep dive today, it should be the sheer scale of the change we are talking about. There is a historical comparison that keeps coming up in our sources, specifically from Demis Hassabis.
Yes. And Demis Hassabis is one of the most measured, thoughtful leaders in the entire AI space. He runs Google DeepMind. He is not a hype man trying to pump a stock. He is a scientist's scientist.
Right. And his quote in the material is startling. He regularly says that AI will have 10 times the impact of the Industrial Revolution, but it will happen in a tenth of the time span.
We really need to reflect on that scale. The Industrial Revolution completely rewrote human society. It changed where we lived, how we worked, what we ate, how we organized our families. It took us from agrarian farms to mechanized factories to modern cities.
It gave us the concept of the weekend, public education, the modern middle class.
Exactly. But that process took roughly 80 to 100 years, several generations.
You had time to adjust. Your grandfather worked on a farm, your father moved to a town to work in a mill, and you worked in a factory. It was a massive transition, but it was a relatively slow transition.
Hassabis is saying, imagine all of that societal change multiplied by 10 in terms of impact and compress it into 10 years. Or less.
That is what it happening truly means. It's the violent compression of history.
And that, right there, is why the METR graph scares the experts. Because looking at that vertical line, they realize we're trying to fit a century of profound structural change into a single decade. And nobody, not the governments, not the financial markets, and not even the pension funds, is built for that kind of speed.
Which leaves us with a final thought for you to chew on as we wrap up. We talked about the ruler running out. We talked about how incredibly hard it is to measure an intelligence that is surpassing the very tests we created for it.
Right. The teacher can't grade the prodigy.
So here's the question. If the ruler breaks, if we can no longer accurately measure the progress because the AI is simply too complex for our benchmark tests, are we just flying blind?
That is the ultimate fear of the researchers at METR.
Are we entering the vertical part of the exponential curve with no speedometer, no altimeter, and no real way to know how fast we are actually going until we slam into the destination?
And if we are flying blind, who is actually flying the plane? Is it us? Or is it the turbulence?
Something to think about the next time you update your passwords or check your pension fund.
Indeed.
Thanks for joining us on this deep dive into the graph that scared the world.
It's been a fascinating, if slightly terrifying, discussion.
See you in the deep end.